Hi, everyone. Today we're going to be talking about identifying rational and irrational numbers. Now, identifying rational and irrational numbers is a lot of vocabulary into it, so let's take a deep breath and then get started. So, rational numbers. Rational numbers are any numbers that can be written as a fraction. So very important, if any number can be put into a fraction in any form, then it is rational. So then that means that if it cannot be written as a fraction, then it is irrational. Okay, simple enough? Great. Now let's look at some examples. Okay, there are many types of examples for each rational and irrational numbers. So let's focus on rational numbers right now. Now, the obvious one is that examples of rational numbers are fractions. Of course, fractions are already written as fractions, so we can see that that is a rational number. So again, examples, of course, are going to be like 1/2 and 3/4, 5/6, anything that is already written as a fraction we know for sure is a rational number. Another example of rational numbers are what's called integers. Integers are going to be positive and negative whole numbers. So for example, 6, -2, and even 0 is going to be an integer. Integers can be written as fractions just by putting the number 1 right underneath it. So again, anything that convert into a fraction is a rational number. Integers, positive and negative whole numbers can be put into fraction mode. Another type of rational number are terminating decimals. Terminating decimals are decimals that end. So for example, 12 hundredths or 5/10ths or 123 hundredths. All of those are going to be going to be rational numbers as well, because we can also create those into fractions, and we're going to see how to do that in a later video. Repeating decimals is going to be another form of rational numbers. Now we're going to be talking about a lot of decimals in these two examples, so let's really get the repeating decimals down. And they are decimals that have the same number repeating forever. So it's really important that you have the same number and, of course, that it repeats forever. If it is a ... at the end, 3 dots, that means that it's going to continue on forever. So we see a couple ones there. 1 repeated forever is going to be a rational number. And in another video, we will talk about how we can convert these into fractions. Another example is 1, 2, 1, 2 repeated. Another way to show that something is repeating is putting a line above the numbers that are repeating. And then our last and final rational number are going to be perfect square roots. Perfect square roots are square roots that equal a whole number. So for example, square root of 1 is 1. 1 can be turned into a fraction. Square root of 25 is 5. 5 can be turned into a fraction. And square root of 81 is equal to 9, which again can be turned into a fraction. So for rational numbers, we have fractions, integers, terminating decimals, repeating decimals, and perfect square roots. Now let's take a look at irrational numbers. Irrational numbers, again, cannot be turned into fractions, and there are certain things that cannot. First off is going to be growing decimals. So as I said before, there's going to be a lot of decimal talk. We have to make sure we understand each one. And growing decimals are decimals where the numbers grow or increase in frequency. So what I mean by that is patterns. So 1, 2, 1, 1, 2, 1, 1, 1, 2, and then with that dot, dot, dot at the end. As you can see, the 1 is increasing in frequency. First, it's occurring once, then twice, then 3 times. Another example would be like 5, 1, 5, 1, 1, 5, 1, 1, 1, and so on and so on. And again, the number 1 is increasing or in the number of times that it's there. So it's looking for patterns. That is called growing decimals. Another part or form of an irrational number are going to be non-repeating and non-ending decimals. So these type of decimals, of course, go on forever, but there's no number that's repeating. It's not just one set of numbers that repeat forever. Instead, they're just random. So the best example for this is going to be pi. Pi never repeats and it goes on forever. You could also create your own by having a decimal and then creating just random numbers in a sequence that with dot, dot, dot at the end show that it just doesn't repeat. It just doesn't show any pattern and it goes on forever. And the last example of irrational numbers are going to be non-perfect square roots. And non-perfect square roots are going to be those square roots that don't equal a whole number. So for example, square root of 11, square root of 21, square root of 99. If you put those in your calculator, you'll see that it goes on forever and it never repeats. It doesn't have a number that repeats in it. So to recap, irrational numbers are made up of growing decimals, non-repeating and non-ending decimals, and then non-perfect square roots. Rational and irrational numbers, again, make sure that you know if a number can be turned into a fraction or not. This is kind of a cheat sheet in order to help you. We will be working on converting terminating decimals and repeating decimals into fractions, so that will be something to look forward to. Good luck.